Well, now let's take a stab at exponential growth. And our exponential growth function equation is almost the same as our exponential decay, except k is a positive rather than a negative. And so let's see, biology. Again, in our sciences, we use a lot of this exponential growth and exponential decay functions. But here we say a type of bacteria is growing exponentially according to the model y equals 1,000, so that's our initial value, E, natural base, raised to the power of k, the constant, times time. It says if there are 1,000 cells initially and 1,650 cells after 40 minutes, find the value of k. So we're simply just going to kind of plug and chug our way through this. So we're going to substitute in, well, if 1,000 cells is our initial value, we're going to substitute in 1,650 for y equals, substitute in 1,000 for A, E raised to the power of k, that's what we're going to solve for, and our time we're told is 40 minutes. Well, I can divide both sides of this by 1,000, then I'm going to get 1,650 over 1,000, and I can at least lop off 1 0 here, reduce it a little bit. I could reduce it further, but I'm not going to. E raised to the power of k times 40. Now let's take the natural log of both sides. And so now we got ln 165 over 100. Remember, I canceled the 1,000 place. Equals ln e k raised to the power of k times 40. And of course, as we know, the natural log and the natural base cancel each other. And so that leaves us with ln 165 over 100 equals k times 40. And we're just going to simply divide both sides by 40. And so we get ln 165 over 100. That's all divided by 40 to equal k. And so k then, when we put that into the calculator, is going to equal 0.125. Oh, got an extra 0 in there. Sorry about that. 0.0125 equals k. All right, well, there's our first model. Now we're going to compare two models of two different bacteria in our next, as we finish up this example. So now we're told that suppose the second type of bacteria is growing exponentially to the model y equals 50 times the natural base raised to the power of 0.0432, that's k, times time. Determine how long it will be before the number of cells of this bacteria exceed the number of cells in the other bacteria. And so we're going to set this up as a greater than. And let's see, so this bacteria, we're going to say that we're asked to find how long before it exceeds or it's greater than. So this starts off at 50 E raised to the power of 0.0432 times time. Time is what we're going to solve for. Is greater than, and our other bacteria was 1,000 E. And that was raised to the power, we found k to be 0.0125. That's what we solved for in the previous example. Also times t. All right, so what should we do? Well, if we apply our product property of logarithms, let's think about doing it like this. So I'm going to take the ln of 50, use my product property, plus ln of e raised to the power of 0.0432t is greater than ln 1000 plus ln e raised to the power of 0.125. Still, I keep wanting to shorten that to 0.0125 t. Now, again, my ln, my natural log and my natural base cancel here on both sides of this inequality. And so now I've got the ln of 50 plus 0.0432 times time is greater than the natural log of 1000 plus 0.0125 t. Well, let's get all the natural logs on one side and everything else on the other. And so then we would have 0.0432 t minus 0.0125 t is greater than the natural log of 1000 minus the natural log of 50. I'm about to run out of room. Now, when I subtract this 0.0432 t, subtract from it 0.0125 t, I get 0.0307 t is now greater than ln 1000 minus the natural log of 50. Let's carry this, got a little bit of room right here. I'm going to carry it right there. And so then when I isolate the t then is equal to ln 1000 minus ln 50 divided by 0.0307. I invite you to pause this video, put that into your calculator, and when you do, we're going to see that time is approximately equal to, greater than 97.58 minutes. So this bacteria here will exceed, even though it only starts off with 50, because it's growing at a faster rate, will exceed this bacteria that had an initial value of 1000 in 97.58 minutes. Shazam.